Hi, my name is Bill Nicholson. The paper I am summarizing is titled Improving the Maintainability of Data Warehouse Designs, Modeling Relationships Between Sources and User Concepts. It was presented in the Proceedings of the 15th International Workshop on Data Warehousing and Online Analytical Processing in Maui, Hawaii in November of 2012. The authors recognize that user requirements, even the data warehouse conceptual design, may use different semantics, different terminology, different phraseology, different descriptions than the data available in the operational data stores. When ETL is implemented, many of those semantics between the operational data stores and the user requirements are mapped. Many of them are not mapped. Those that are mapped are lost, and those that are not mapped may be needed later to implement changes to the data warehouse when user requirements change or when the underlying operational data sources change. The authors took on the challenge of devising a set of semantics to capture this lost information to preserve the mapping between the operational data stores and the user requirements. The approach was to create a model that could be used during reconciliation, then could be carried forward to preserve the information captured during reconciliation, even capturing the information that was not used during the reconciliation process but may be needed later. A new set of relationship semantics is defined. The diagram here illustrates where that modeled relationship appears in the process. The reconciliation process generates information. The operational data stores, particularly the schemata of those stores, and the user requirements, also referred to as concepts, generate information. Those three information sources generate the model. The model can then be used as part of the ETL process. The model can also be used in the future to support modifications to the data warehouse, which may reflect upward into the ETL process, or to support modifications to the data warehouse when the underlying data sources change. The semantics that were modeled are relationships between attributes from the two different sources, relationships between levels of the same attribute, and the dimensions along which those attributes are measured. The semantics describe two things: whether or not these types of concepts overlap, containing more or less information than their counterparts, and whether or not the information conflicts. This diagram illustrates the taxonomy of how the semantics are built. There is a category of overlap and a category of conflict. The application of overlapping and conflicting semantics can be viewed in this manner. Overlapping breaks down into four different categories: equivalent, subset, superset, complementary. The first diagram on the slide represents an equivalent set of attributes where they are containing the same information. The second diagram illustrates the subset category of overlap, where one attribute contains more information than the other, but there is still some overlap between the two attributes. The third type of overlap, the superset overlap, contains or describes the situation where one attribute contains all the information in the second attribute and then additional information as well. The fourth type of overlap, complementary, illustrates a situation wherein the attributes do not intersect at all. The conflict semantics describe three conditions wherein there is a function f that exists that can map the attributes from the operational data store into the attributes of the user concepts or the conceptual data warehouse design. An irresolvable conflict exists when that function does not exist, when there is no mapping. and the conflict called no relationship exists when it is not relevant to attempt to find such a function. The results are illustrated here. We can see that a irresolvable conflict exists between the language dimension and the document dimension. We see a solvable conflict that exists between the name and the language. Again, on the left we have our operational data sources. On the right we have our data warehouse design. Here's another example of a solvable conflict where the alphabet used in the target data warehouse can be mapped into the document semantics used in the operational data source. For future work, the authors plan to contrive useful tools for measuring the metrics generated by these semantics to look for trends and possible ways to improve the design and implementation of the ETL process. Thank you.